Okay, reads, carry out a chi-square test for goodness of fit for the studies below. Use 0.05 level of significance. So click on the icon to view the table of cut scores, okay, for the chi-square. So state the null and research or alternative hypotheses. Choose the correct answer below. Okay, so the null is that they are the same. So it's definitely not B because it says that they're different. And the research hypothesis is that they're different. So C, not just for one category, but here we go. Determine the cutoff sample score on the comparison distribution in which the null hypothesis should be rejected. So again, we're using cut scores here. So here are cut scores. We're at a 0.05 level of significance. Our DF is n-1. We're looking at part A now. And we got 5 categories. So 5 minus 1 is 4. And so we're looking at 9.488 is our cut score. So when we compute the chi-square statistic, if it is greater than that, then we're going to reject HO. So it's the same thing we've been doing with t-test, with ANOVAs, if we're looking at that critical value. So although we're often using the p-value method, it's still good to have a sense for what that test statistic is showing you, because research articles will almost always report that test statistic. So what I say here, cut score is 9 to 3 decimal places, 9.488. Okay, to run a chi-square, we're going to go to stat. And we're doing, it says run a goodness of fit. So goodness of fit, chi-square. So the observed are in the observed. And then the expected are in the expected. And we can display expected, residuals, standardized residuals, etc. We'll just do the expected, press compute, taking all the default, didn't really change anything. And there we go. So there's my chi-square. Notice n is 425. So if I added up all these here in the observed, I get an n of 425. We're given a p-value here. So we have 10. It says round to 3 places, 10.886. So now we're going to decide whether to reject the null hypothesis or not. Now notice our test statistic is greater than our cut score, so it's in that rejection region. Also, when I ran this, I got a p-value less than 0.05. I got 0.0279. So both they should always align. Possibly due to rounding, if it's right on the edge, you might get one a little bit where you do and the other one you don't. So we are going to reject HO. Notice also we hear, what is this other one, the observed. These are given in percents, and so if I took 29% of the 425, my expected would be 123.25. So they gave this in percents over here. So these are just the raw numbers right here. So again, if we're going to reject HO, that they're the same, that means we're supporting the fact that they're different. So reject HO, the research hypothesis, the distributions of the two populations are different, is supported. And now we're basically doing the same thing for B. And part B is exactly the same as part A. I'm going to let you do part B on your own. Only difference here is in number in the past. That's sort of implied that's what we're expecting. So you would choose that column for expected. So I hope that helps.